Last year's AI Day was particularly exciting because Musk revealed Tesla was working on Optimus, a robot designed to eliminate dangerous, repetitive, and boring tasks, and capable of following natural language commands, such as pick up that bolt and attach it to the car with that wrench. Musk also promised a working prototype for 2022's AI Day, which excited some while reminding others of Musk's tendency to overpromise and underdeliver. Welcome to First Class Tech, and in this video, we'll take a look at why Tesla's Optimus bot was better than anyone expected. Musk gave way to the Tesla bot 5 minutes in, to cheers and applause. The doors opened, revealing a standing human-height, shell-less robot with visible cables and motors. It walked, turned, waved to the audience, and did a small dance. As Musk later explained, this was not Optimus, but a development platform called Bumblebee, which was constructed from the off-the-shelf parts and was used to design and test the robot systems and modules. Bumblebee's next-generation production-ready evolution is Optimus. They then showed several videos of Optimus performing tasks other than walking and waving, such as transporting boxes with its hands, grabbing and using a watering can, and holding and moving a seemingly heavy metallic object. Although robotic experts describe this as standard for humanoid robots, there are a few features that make the Tesla bot worth watching. Humans create the world for human use. That is the most compelling reason to build a humanoid robot rather than any other shape. The human body's flexibility and versatility are unparalleled. The design of Optimus's joints and actuators reveals the intention to mimic our anatomy. The bot's hands, for example, have 5 independently moving fingers and opposable thumbs, and Tesla claims they can grasp adaptively, with strength or precision, and use tools. However, evolution is a continuous optimization mechanism that searches randomly, which necessitates trade-offs that intelligent design can avoid. Following biology steps blindly isn't always the best approach. A plane is the most common example. Optimus is no exception. The human body has numerous degrees of freedom, but there is no need to go to such lengths to incorporate such sophistication into a robot. Optimus has 28 plus hands, which allows it to move the arms, hands, and each finger independently, demonstrating a reasonable dexterity. Biology isn't the most efficient master either. The human body isn't as efficient as it could be, which is something Tesla engineers are working on. Cost and efficiency are priorities when designing a robot for mass production at scale. By the way, if you're watching us for the first time, make sure to hit the subscribe button and turn on notifications so you can enjoy our future videos while getting updated. Getting back to the topic. Musk argued last year that Tesla is not a car company, but rather, arguably the world's largest robotics company. Self-driving cars are easier to create than humanoid autonomous robots, but both are robots that fall under the category of real-world AI. This means that the AI that powers self-driving cars can be easily transferred to Optimus, even if it is incomplete and imperfect. This distinguishes Optimus from its more agile and physically capable cousins. In terms of athleticism, BD's Atlas is years ahead of Optimus, but it lacks AI power. Given Optimus's broad scope, it's difficult to compare it to most other humanoid robots on the market. It competes on both the physical and cognitive levels. Other humanoid robots, according to Musk, are missing a brain. They don't have the intelligence to navigate the world by themselves. People keep saying that BD is years ahead of Tesla, but comparing Optimus to Atlas isn't a fair comparison. First and foremost, the objectives are vastly different. Second, Tesla engineers created an Optimus prototype in less than a year, whereas BD's Atlas is more than a decade old. But how did this happen? How did the engineering team accomplish this in less than a year? Musk explained how Tesla's vertical integration would allow them to transfer and integrate self-driving car technology into a humanoid body. Tesla's engineering expertise and infrastructure are well suited to the challenge, with a focus on autonomy, supercomputing, neural nets to recognize the world, and real-world AI, sensors, and actuators in general. Tesla engineers determined the rupture threshold for the joints and parts using structural analysis simulations and damage control. They used their manufacturing expertise to evaluate the best standard actuator designs, transferred the FSD hardware and software into the robots, and integrated trained neural networks into the bot's vision modules. Musk emphasized that one key difference between Optimus and other impressive humanoid robots is that the Tesla bot is intended for mass production. As a result, low cost and high efficiency requirements are top priorities. Robots like BD's Atlas are very expensive and made in low volume. according to Musk. Tesla wants Optimus to be an extremely capable robot produced in large quantities. He also stated that they intend to build millions of units that will cost much less than a car, probably less than $20,000. BD's Atlas is an extremely expensive research platform. The cost of BD's robotic dog, which is a consumer product, is $75,000. That's 3 times what Musk has promised for Optimus in the next few years. Atlas, on the other hand, is not intended for mass production. In this regard, Optimus is similar to Agility Robotics Digit, a factory work robot designed for mass production. Agility Robotics, which is now backed by Amazon, has a few years head start on Tesla, but does not have the latter's optimized infrastructure. In the near future, Optimus and Digit may become direct competitors. Now let's get into the not so fun stuff. Optimus's limitations and flaws, both obvious and not so obvious after watching AI Day. The engineering team at Optimus achieved a quick turnaround, but it is still insufficient in the absolute sense. Colors, textures, flavors, odors, temperature, pressure are all perceptible to humans. Our brain has multiple senses. Our perceptual systems capture the world's multimodality, which our brain integrates into a single representation of reality. You can see the reddish color of an apple, taste its sweetness, smell its fragrance, and feel its soft touch when you eat it. Everything is present at the same time. Optimus isn't supposed to taste or smell, but it will need vision, tactile and haptic sensors, proprioception, and a representation of its body to know how far it can move. Tesla engineers stress the importance of instilling Optimus with a sense of self-reference, proprioception, balance, and coordination. Of course, quality and level of skill are extremely important. Having a hazy idea of where the hands are isn't comparable to human proprioceptive abilities. Optimus, the one who could walk, appeared to be quite sensitive to disturbances. For example, BD's Atlas has proven to be quite remarkable at maintaining balance under adverse conditions. Human perceptual systems generate an excessive amount of data. The brain uses attention to determine which events or objects are prioritized. Optimus must navigate the perceptual space in the same way. The combined power of the multimodal perception and attention would provide Optimus with a very good sense of the world's complexity, while also allowing it to make decisions based solely on the most critical and pressing information. Tesla engineers demonstrated Optimus's planning abilities briefly, but did not go into the details of decision-making and the difficulties of creating functional, real-world robots that can act in the world in accordance with their goals, while overcoming unpredictable challenges. Even if Tesla's self-driving cars can get from point A to point B without collapsing, the technology is still unreliable in extreme cases. This means that self-driving cars are still a work in progress. The technology isn't ready yet because there's too much variability in the world, and the same limitations that apply to cars also apply to Optimus, multiplied by the increased complexity of the scenarios it would face. Even though Optimus has excellent vision, it lacks a natural language interface. In any case, calling Optimus an autonomous robot is a stretch. Humans with true autonomy have developed that autonomy over millions of years of evolution. Making an autonomous general-purpose humanoid robot is likely the most difficult challenge AI faces right now. Even if Tesla engineers aim to build a biology-inspired AI-powered robot, they will not be able to create something that does everything a human does, as they boasted. At any level, Optimus is incomparable to humans. Despite the obvious limitations, we were impressed by what Tesla demonstrated. Building a walking robot is difficult when you only have a year to complete it, but we shouldn't just look at these results in relative terms. In absolute terms, what Tesla demonstrated was, while more than expected, less than required. And with that being said, it's time to end our video. What were your expectations from the Optimus bot? Let us know in the comments. Like this video and make sure to subscribe to the channel for more amazing videos like this. We'll see you in